So another technique that we could use is we can multiply an existing power series by a polynomial. So as an example, let's find the power series representation of x cubed times e to the x. So remember, e to the x is equal to sum from k equals 0 to infinity, 1 over k factorial times x to the k. So if I write x cubed times e to the x, I could rewrite that as x cubed times the sum from k equals 0 to infinity, 1 over k factorial times x to the k. And now the thing is, let me rewrite that because I kind of made a hash of it. So now the thing is, I can treat this x cubed and this x to the k as using the fact they're the same thing. Okay, so x cubed times x to the k is equal to x to the 3 plus k. But if I distribute that through, now I can just say that's equal to sum from k equals 0 to infinity of x. This should be 1 over k factorial, sorry. 1 over k factorial x cubed times x to the k, which is the sum from k equals 0 to infinity, 1 over k factorial x to the 3 plus k. So this would be my final answer, and this would be an expression that is equivalent to x cubed times e to the x. Now what about something like t of x is equal to x to the 5th minus x times e to the x? We're going to do the same thing. We're going to use the fact that e to the x can be represented by the power series, the sum from k equals 0 to infinity, 1 over k factorial x to the k. We're just going to replace that here. So we can write out that power series expression. So this would become x to the 5th minus x times sum from k equals 0 to infinity, 1 over k factorial x to the k. Now we can take this and distribute it through. So we have t of x is equal to the sum from k equals 0 to infinity of 1 over k factorial times x to the 5th minus x times x to the k. And so we have t of x is equal to the sum from k equals 0 to infinity of 1 over k factorial times x to the 5 plus k minus x to the 1 plus k. If I do the algebra, x to the 5th minus x times x to the k. Now some people would want to rewrite this as the sum from k equals 0 to infinity of x to the 5th plus k minus x to the 1 plus k over k factorial. Either way, they're the same thing. I would personally prefer to have it this way, but this is a power series representation for this function. So for our next example, let's do finding a power series representation for big R of x is equal to x over 1 plus x cubed. Now we need to recognize that we have this denominator with a 1 plus something. And when we see that, that might make us remember, wait a minute, I know something about 1 over 1 minus x. So I know that 1 over 1 minus x is equal to the sum from k equals 0 to infinity of x to the k, as long as the absolute value of x is less than 1. So that means that 1 over 1 plus x cubed can be rewritten as the sum from k equals 0 to infinity of, well, think about this relationship. 1 over 1 plus x cubed is equal to 1 over 1 minus negative x cubed. I can take this negative x cubed and replace it everywhere I see a... So the upshot is that the power series from 1 over 1 x plus x cubed can be rewritten as the sum from k equals 0 to infinity of negative 1 to the k times x to the 3k. Now we're going to take that, and so we're going to rewrite r of x is equal to x times 1 over 1 plus x cubed, and then r of x would be equal to x times the sum from k equals 0 infinity negative 1 to the k times x to the 3k. And we're going to take this x and just distribute it through, and that becomes r of x is equal to the sum from k equals 0 to infinity, negative 1 to the k, x to the 3k plus 1.